functions and relations. We're going to actually take 2 days over this next section. We're going to break it into half. Okay, and so the first day what we're going to do is we're going to just basically look at this graph and we're going to make some inferences. So it says the function f of x equals negative 5x squared plus 50x approximates the profit at a toy company where x is marketing costs and f of x is profit. Another name for f of x is y. Okay, so think of it that way. X is costs, y is profit. So how much they make? Both costs and profits are measured in tens of thousands of dollars. Use the graph to estimate the profit when marketing costs are $30,000. Confirm your answer or your estimate algebraically. So if marketing costs are $30,000, where is that down here on the graph? Between 2 and 4 here at 3, right? So we just want to find the profit. So all we're going to do is follow this line up, and we're going to see that the profit is about right here. So what do you think that is as an estimate? Okay, now it's going to be a little bit more because everything's in tens of thousands. So really, 100 is actually 1 million. And I think it's a little bit above 1 million because it's not exactly at that 1 million mark. So I don't know, let's just say 1,050,000. Okay, that was the guess I took last period, just because it's a little bit above, and each of these goes by 25. See, like this would be 75, this would be like 125. So now it says confirm your estimate algebraically. So all you're going to do is, your x value here was what? What was your x value in the part? 3. So all I'm going to do is take 3, and I'm going to plug it right in here for x. What is 3 squared? Times negative 5? Negative 45 plus 150. So that actually gives me 105, which was right on line with this. So there you go. That's it. So we're doing a lot of graph reading today. Let's look at another one. This is the exact same problem. So we're just going to jump to the question. It says use the graph to estimate the marketing costs when the profit is 1.25 million. So where would 1.25 million be?
Like between the...
Yeah, above the 100, like you said, because each of these goes by 25. Because this is 25, this is 75, this is 125. So all I'm seeing is, okay, where does this equal it at?
5.
At 5, good. So this is 5, right? What would the marketing be? $50,000, very good. Now it says, estimate your result algebraically. Well, I'm going to let you do it the easy way. Okay? If you were doing the 125, you would set it equal to 125 and you'd have to solve it, which is a little bit tougher. The easy way is just to put 5 in here for x and see how close you are. Okay? So if I plug in 5, 5 squared is what?
25.
Times negative 5 is? Negative 125. Add it to, what's 50 times 5? 250. What do you get? 125, which is exactly what I was here. So it matches. So think you can handle looking at graphs and saying what they are? All right. Now we're going to do domain and range based on what you're looking at. Now let's think. Domain and range. Domain meant left to right. Range meant bottom to top, up and down. So that's what we got to think. Left to right, bottom to top. That's the order. So now I'm looking left to right. So I'm starting here at the leftmost point. How far left does the graph go? It only goes to negative 3. It doesn't go further? It keeps going, right? So it's going to keep going no matter what. So negative infinity, very good. How far right does the graph go? Positive what?
3.
Do I include 3 or not?
Yeah.
Yes, because it is closed. See that closed circle? So, left to right. Now remember, what was range? Bottom to top. So how far low do I go? Negative infinity. How far up do I go? Positive 2. Do you include positive 2, yes or no?
Yeah.
Yes, because it is at the point right here and also here. And you only need one of them to work. That's it. That's the domain and the range. Yes.
For the domain, where did you get the 3 again?
Because 3 is the x value right here at this specific point.
Where it's closed.
Right, yep.
And
Because
that's
you're
just
always going left to right.
down?
What?
That's just going down?
No, it's not going down. It's as you look left to right. So you're looking strictly on this x-axis right here. And I'm starting the left. It keeps going, so this would be the left. And then as I move across, what x value does it stop at? It stops at 3. See, there's nothing after 3. So let's look at, did I skip? No, I don't think I skipped one. Okay, the domain here. So we're starting left first. What's the leftmost point?
Negative infinity.
Leftmost point.
That's, oh, it's
Negative.
negative
-3, good. Okay, leftmost point is right here. Do I include it or not?
No. I got you.
I do not include it. So now, what's the rightmost point that I go? So I'm here at the left. Where do I go where I stop?
1. Or no.
Infinity.
Infinity, very good. The reason why you don't do anything with these points right here is because this point here kind of cancels out this point here. And see, then it just keeps going on forever and ever. Okay? But we will use those points in a little bit. The range, let's start. What's the lowest point you do? Negative infinity. So let's travel up the graph. Where do I go to now? Where do I stop?
-1.
-1. Do I include -1 or not?
Yeah.
Why no? Because it's
Oh,
open.
it's open.
It's because of this one right here. So to -1. So then now, where else do I go? So I go from negative infinity to +1. Where's my next value? +1, good. And that's just a value, so you're just going to leave it at 1. Because see, it doesn't go above 1. So 2 ways you could answer this. You could put your union symbol, which was U, or you could do a comma. All right, let's look at this one. You try this one for me. Domain and range. So if you don't know, take a guess.
So domain is left, right?
Yes.
range is up.
Bottom to bottom. Good. I'll take one of them. Almost. You're close.
Like this?
They're close. You got the number. I'll tell you, you got the number right. You just got this. You got some of the symbols wrong. Okay. Those each they don't go by ones. You're almost right. They don't go by ones. Because if you look, you go from 0 to -4.
So it's
There you go. Yep. And other than that, though, the numbers would have been right. All right. So leftmost point. What's the leftmost?
-4.
Negative
Or 2.
2. Do you include it or not? Yes, because it is closed. Okay? Now, rightmost point, that was the only one you made on the first one. Rightmost point, 6. Do you include it? No, because it is open. Okay? So there's your left to right. So now we got to go top to bottom. What's your lowest point on the graph? 0. Do you include it? Now, some of you are probably like, well, this one's open and this one's closed. It doesn't matter. You just have to have one. Okay, so since this one is closed, that automatically closes 0 off. How high do you go up? 4. Do you include it or not? Yes, because there's a point right up here at 4. So you like those better looking at graphs? Or do you like doing them the way we did Friday? Graphs. I figured that. Okay, so x-intercepts, y-intercepts, and this is the last concept we're going to cover. And so x-intercepts occur where y equals 0. Y-intercepts occur where x equals 0. So if you look, I have 3 x-intercepts. Boom, boom, boom. And I have 1 y-intercept here. Okay. So x-intercepts occur where y equals 0. y-intercepts occur where x equals 0. So what we're going to do is we're actually just going to look at graphs and find out what the intercepts are. It says use the graph of the function to approximate its y-intercept, then find the y-intercept algebraically. So looking at the graph, where's the y-intercept?
5,
4.
4.
1. Okay, so the y-intercept is actually at the point 0, 4. Yes, you need to answer it that way. I don't just want to see 4. So then now it says find the y-intercept algebraically. So all you're going to do is plug in 0 for x. So if I plug 0, 0, I end up getting 0, 0, and then what am I left with? 4. Checks. Boom. You're done.
So you do 0 for every.
For the y-intercepts. Let's look at this one. Use the graph of the function to find the y-intercept. Where's the y-intercept at?
-1.
Okay, so let's figure out how am I going to write that?
0.
0, -1, because that's what this point is. So next, all I got to do is plug in 0. I get 2 minus 3, which is checks.
So if it doesn't check, does that mean you did something wrong, or
Yep.
it just doesn't?
Wait, what do you mean?
It will always,
It matches this one.
so it will always.
It will always match, and if it doesn't, then you've done something wrong. Okay, what's your y-intercept here?
0,
2.
0, 2, yeah.
0, 2. So once again, let's plug in 0. 0, 0, and you get 2. Check. So now this one says use the graph to approximate its zeros. A 0 is a fancy name for the x-intercepts. So instead of just telling you to find the x-intercepts, they're going to say find the zeros. That's all. So we're going to do it the exact same way you just got done doing the y-intercepts. Where are the x-intercepts here?
-1.
Okay, so -1, 0 is my first point. Where's my next one? 0, 0. Where's my next one?
0, 1.
1, 0. Okay? So then now all we're going to do is we're going to plug those values in. So I'm going to plug in -1 right here. What is -1 cubed? Minus -1, which is?
0.
Check. So now I'm going to plug in 0. I get 0 minus 0, which is? Check. So then now I get 1 cubed, which is minus, which is? Check. All right. Where would the 0 be here? At 5. So how am I going to write that?
0,
5, 0. So once again, then all I'm going to do is plug in 5. So I end up getting the square root of what? 9 minus 3, which is 3 minus 3, which is? All right, this is the last thing we're going to end. Now, I don't want you to write down this whole thing in your notes. We're going to pick up with this tomorrow. And so what I want you to do so that we can just start tomorrow and you don't have to write this down, you probably want to put this in your notes. That's your title of this table. And then what I'm going to want you to do is I'm going to want you to have 3 parts. This first one is x-axis, and then you need to have replace y with -y. When you get done with that, you need to do y-axis, and then replace x with -x. And then you need to do origin, replace x with -x and y with -y. So those are the 3 things that you need to copy down. Now what I'm going to do is I'm eventually going to go back to this, but for those people watching the video, I'm going to go directly to the assignment. Now this assignment is a 2-day assignment. Now I will go back to that page. Oops. But this is your assignment, pages 19 and 20. It's 2 through 44 of the evens. You should be able to do roughly half of those tonight, which is only 10 problems. Okay, because 2 through 44 is roughly 22 problems. Half of it's about 11. Okay, so